It says, empirical research on a stock market data for 2 consecutive trading days indicates that 40% of the stocks that went up on the first day also went up on the second day. Yesterday, 600 stocks went up. Find the mean. The mean is the expected value of, they call that p hat. The expected value is just the percentage. So in this case, it's going to be 40%. We're going to write it as a decimal, which is 0.4. So when they ask you for the mean, they're just asking you for the percent that you expect it to be. Standard deviation. To find the standard deviation, you are going to take the square root of the p hat times 1 minus the p hat, which sometimes they call q hat if you see that in the book, over n. So, I am going to do the square root of my p hat, which was my 40%. 1 minus p hat would be my complement if 40% of them went up, 60% of them went down, right? So that's going to be the 0.6. 1 minus 0.4 would be 0.6, or 60%. Over n. N was 600 stocks. And then we're just going to punch that into the calculator and figure out that number. P hat was 0.4. 1 minus 0.4 was 0.6. And we got what for our answer?
0.004.
0. Whoops.
Or is that right?
So, not quite what I got.
Okay.
Okay, let's see what you typed in there. So square root. Maybe you didn't do the square root. 0.4 times 0.6. And then you want to highlight that.
So this should be a 0.4?
Yep, that was 0.4, okay.
Okay.
And then you want to highlight that. Whoop, not quite that far. Will it let you do just the other part? There we go. And you want to divide that by 600. That looks like the fraction, right? All right, that's what I got, 0.02. And if you have a hard time punching that in, just multiply this number out first and then use the number you get when you multiply it out. All right. So now it wants us to compute an approximation for p hat is greater than 0.38. Notice that's a greater than, and so whenever it's a greater than, we have to start off with 1 minus the other one, right? So I'm going to do 1 minus, oh, I got to do my formula yet. Well, I'll get there. 1 minus p of z is less than or equal to. Now this is going to look like our other formulas that we put in, sort of. This is our sample mean, so we're going to use the 0.38. We're going to subtract the expected mean, which was the answer for part A, 0.4. And then we're going to divide it by the standard deviation, which was the answer to part B, 0.02. So that number went here, part A answer went here, part B answer went here. X minus the mean over the standard deviation, but they just have us calculate the mean and the standard deviation ahead of time. Round our answer to 4 decimal places, it says this time. Let's try that again. So we have 1 minus p of z, okay, and then on the top we have 0.38 minus 0.4 And we highlighted that little part. Yep. And divided that by 0.02. That looks better. 4 decimal places we want to round that off to
0.41.
0. What?
0.8413.
There we go. 0.8413. Okay. So this formula here basically is the same formula we did before. We had our sample mean minus our mean over our standard deviation. They just had you calculate those ahead of time so you had your numbers. All right. Number 14. The credit risk department of a major bank estimates the default rate on a loan under $10,000 is to be 2%. The bank will make 1,600 loans that are under $10,000 next month. Find the mean of P hat. So my mean is going to be what number? Nope.
16. I don't know.
Look at your previous problem. What did we use for part A? 40%. What percent do we have this time? 2%. 2%, which means we're going to use 0.02 for our answer for our mean then, right? Okay? Standard deviation. We got to find the standard deviation. If this is 2%, then our other number would be 1 minus 2%, which is 98%, right? Over n. N is the number of loans. 1,600, right? So we had the square root of P hat and then 1 minus P hat over n. So when we calculate the standard deviation, what do we get? Yep, 0.0035 is what you should get. Yep. Part C, again, we want to calculate it for it being greater than. Since it's a greater than, we have to do 1 minus, right? So 1 minus P of Z is less than or equal to. And our number that we're going to use first is the number that's given here in our word problem, 0.015. We're going to minus the answer from part A, which was our mean, 0.02, and we're going to divide it by the standard deviation, which was our answer from part B, 0.0035. We're going to round to 4 decimal places, it says.
.9234.
Yep. 0.9234. 92.34% probability that that will happen. All right, last one of chapter 6. So a researcher wants to investigate the effects of the environmental factors on IQ scores. For an initial study, she takes a sample of 400 people who grew up as the only child. She finds that 51.5% of them have an IQ over 100. It is known that 50% of the general population has an IQ score exceeding 100. Find the mean where a mean of p hat, where p hat is the proportion of people with the IQ scores over 100 in the random sample of 400 people. They're trying to be tricky on this one because they gave you more than 1%, right? So when I am going to find the mean, I'm finding the mean of the known, not the mean that they found when they did the sample. So the mean of the known is 50%, right? So when I'm doing this one, my mean is going to be 50% or 0.5. So that's the percent you want to use when they give you more than one. You want the known percentage. We want to then find the standard deviation. How are we going to find the standard deviation? Our p hat is 0.5. 1 minus 0.5 would also be 0.5, right? Mm-hmm. If 50% did, then 50% didn't. And the number is 400 people, right? 400. And so our standard deviation is going to be
0.079.
whoops.
Oh.
All right, square root of 0.5 times 0.5 again. Highlighted that and divided it by 400. There we go. What do you got?
0.025.
0.025. There's my standard deviation. Part C again, notice we're doing greater. Anytime we have greater, we're going to start with 1 minus, right? 1 minus P of Z is less than or equal to. And what numbers would we put in for our formula? Yep. We use the number from the word problem, the 0.515 first. And then we subtracted what number? Whoops.
Oh.
That's the bottom number. The 0.5. That part A answer. 0.5. And then we divided by the 0.025, right? So this was our part A number. This was our part B number. And we punched that into our calculator and rounded it off to 4 decimal places.
2742.
Does that round up to 3?
Whatever.
Whatever. Is there a 5 after it? I wrote a 5 down after it.
I don't know. That's what I have.
0.27425. Yep, so the 2 we round up to a 3. Alrighty. So that last half, just using the same kind of formula and different variations depending on what we know in our word problem. And just punching your numbers into the formula and hopefully getting them punched in right.